Okay, so we have finished section one, and we'll have a test on that sometime in the not too distant future. But we're going to go on to start section two. Please be reminded, in case you haven't bothered to look at the calendar, that you have chapter 5 quiz on Monday. And then our part 1 test will be on Wednesday. Okay? So we're starting this, but we won't get too far into section 2. So when dealing with univariate numerical data, so that's just one variable. When they say univariate, people are like, what? And I'm like, this just means uni, one, variate, variable. Our two primary pictures are histograms and to a lesser degree box plots. Today we're going to start looking at bivariate data, where you have two different variables, which frankly is what you've mostly done with variables in high school math classes. You had two variables. So first of all, scatter plots. Are the best way to start observing the relationship between two quantitative variables. Notice it has to be two and it has to be quantitative variables. They help us to see if there is an association between those variables. You have to be really careful about using the correct words on this. And honestly, I'm still occasionally bad about it because I used the wrong word for, 50 some odd years. And then it's like, oh yeah, I've been using the wrong word all along when I started learning statistics. So I'll try not to use the wrong word. So the direction of a scatter plot is positive if the data tends to move up as we view the graph from left to right, and negative if the pattern is running the other way. So if as one variable increases, the other one does as well, then that tends to be positive. Case in point, calorie consumption, weight gain. More calorie consumption typically gives you more weight gain. Okay? It's not 100%, but you get the idea. There are other ones that are inversely related, or it's a negative direction. So for example, if you measured someone's blood alcohol level and how good they were doing a particular task that required some sort of manual dexterity. As the blood alcohol level goes up, the ability to do the task goes down. Now be careful, if I change that slightly, I could make it blood alcohol level and the time it takes to complete a task. Right? As blood alcohol level goes up, the time that it takes to complete the task also goes up. Those have a positive direction in their association. So then the form of the scatter plot is whether the points generally, and this is very generally form a line or not, or if they're curved in some way. Some simple curves we will be able to straighten, and we'll talk more about that later. But if you get something that's U-shaped, usually there's not much we can do with it. You can't do anything to straighten it. Then the strength of the relationship is the tightness of the clustering about the form. We'll talk more about that also in just a moment. how strong the association is. Now, an outlier is a point whose output values, its y values, is the way you usually think about them, but we won't think about them as x and y very often, that is either far above or far below other points with similar input values. And then a high leverage point is a point that's far away from the other data in the set. If you have a high leverage point, even if it's nearly on, like say, you have a positive direction in the association, and all the data ends here, and then you've got this other point way up in the corner, sort of like this one. A little change in that one, because of how far it is away from everything else, tends to change the equation we get for the line of best fit. Because it's a long way away, any little change tends to change it a bunch. If you change one of these a little bit, it's in there in the herd. It doesn't really matter a whole lot. So let's take a look at these. So, is this positive or negative? Positive. As one variable increases, so does the other one. Is it linear?
Yes.
Yeah, it's generally linear. Strong or weak?
Strong.
That's pretty strong. And here's the deal. If I kind of thought about drawing an ellipse around these that, got everybody inside of it, and it was really an ellipse. The longer the ellipse is compared to the width of the ellipse, the stronger it is. Right? If you think about having one that was a line, it wouldn't need to be very wide at all, would it? Okay? The more circular it gets, the weaker the linear pattern is. Now, if it's something else, that's a different deal. But if you're looking at something that's basically linear, you're kind of measuring, how long it is compared to how wide it is. And we'll eventually talk about how to actually get a numerical value for that. All right, what about this one? Positive or negative? Negative. Linear or nonlinear? It's linear, but is it strong or is it weak? Yeah, it's fairly weak. Now you'll get some where you're like, yeah, maybe it kind of is linear, but generally speaking, this kind of, yes, it would be, if you had to draw an ellipse around this, it's not quite a circle. It is longer than it is wide. And that's what gives you it's fairly weak. All right, what about this one? Notice this one is neither positive nor negative. Is it linear? No. So it's nonlinear. But, if you kind of superimpose a parabola in there, are they all pretty close to that?
Yes.
So it tightly fits that form. It's just not a linear form. So it's fairly strong. How about this next one? Yeah, there's no real pattern here, is there? Sometimes as you move to the right, things go up. Sometimes as you move to the right, things go down. So we would say that there is no association. Now, for this last one, we won't talk about all those things. I just want to talk about the difference between outliers and high leverage points. So on this, there's a fairly strong negative linear association, except for these 2 points. Those are your outliers. Although these are a long way away from them, the rest of the data, are they kind of along the same line?
Yeah.
We'll typically call those high leverage points. And again, the idea for that is pretty simple. Think about it this way. You've all taken physics, yes? Not yet, slacker. And so if you have something that you want to lift, right? If the weight is here on the eraser end of this pencil, if I have my lever is like this, I don't have a lot of strength. But if I put it like this, now I have a lot of strength because it's a long way away. So it can lift that a lot. It's sort of like that. It's the way I think about it, at least. All right. The variable of interest is called the response variable. And it's always on the vertical axis. And the other is called the explanatory variable. For those of you who are using a TI, you want to make sure when you're doing this kind of stuff that you have the diagnostic on. So, wake mine up, clear that out. I tend to use the catalog a lot to find things. So I'm going to do second 0 to go to the catalog. And then rather than having to scroll through all of these, if I can find D, which is right here, that jumps down to the D's, and so I don't have to scroll as far. And you just turn the diagnostic on. You just hit enter and hit enter again. You're going to want that so that when you do a 2 variable where you go into stat and you have the first variable in L1 and the second variable in L2, when it does the analysis, it gives you additional information if it has diagnostic on. Now, why diagnostic off is the default setting? I'm like, well, why would you do that? Why would you make people turn that particular feature on? The answer is I don't know. Okay, when you're doing a scatter plot, and you have data in this, and I'm just going to make up some junk. How many of these are there? Okay. So if you go into statistics, calculate, you now do it with 2 variable stats instead of a single variable. And you tell it to calculate, and it gives you all this different information. It gives you the average X value and all this information about X, and it tells you how many there are. It gives you the average Y value, tells you the standard deviation for Y. It also gives you the mins and the maxes. It gives you all this different stuff. Did I not turn the diagnostic on? Catalog, diagnostic on, where's D? Doop. Stat, calc. Oh, we'll talk more about this next week. We want to do a linear regression. When you have the regression on, it gives you not just the equation, but it also gives you R squared and R. And we'll talk more about what that means next week. Because I want to give back your quizzes right now.